I am back. I am back. Marine Arnold Chicago as usual, trying to break down, the little chemistry, Yeah. So B is more electronegative than we have seen that here B is more electronegative than A. Therefore, B pulls or attracts bonding electrons strongly towards itself. So meaning that this line you are seeing, that line now becomes polar covalent bond. It is a polar covalent bond because one atom is more electronegative than the other. Also, I want to say that in this case, kindly put these words, in this case, B acquires, in this case, B acquires a partial, B acquires a partial negative, B acquires a partial negative charge, B acquires a partial negative charge, leaving a partial, positive, leaving a partial positive charge on A. In this case, fix that thing. In this case, B acquires a partial negative charge, leaving a partial positive charge on A. So this is how we represent a partial negative charge. So we have a partial positive charge. So I am saying that once you have a line, once you have a bond between atoms, where one atom is attracting electrons strongly, towards itself, that bond is polar. Moreover, that thing which is attracting electrons strongly is more electronegative. I repeat this. Let me summarize this. I have said that polar bond kitegeeza ki? Polar bond means one atom is more electronegative. Means that one atom is more electronegative. Therefore, if one atom is more electronegative, so it pulls bonding, it pulls the rope, pulls bonding electrons strongly, towards itself. One atom is more electronegative, it pulls bonding electrons strongly towards itself, therefore acquires a partial negative charge, acquires a partial negative charge, leaving partial positive charge on the other atom. One atom is more electronegative, it pulls bonding electrons strongly towards itself, acquires a partial negative charge, leaving partial positive charge on the other atom. Yeah. So this is the animation. Allow me share. Okay, before I share. For example, if I have HCl. Now you see, in your O level you are writing H with a plus and Cl with a negative. But you people, you were not knowing where those charges were coming from. H with a plus and Cl with a negative. We are writing that thing in O level, in ordinary level. Now, do you know where it comes from? In this case, are you seeing this chlorine? This chlorine is more electronegative. This chlorine is more electronegative. It is more electronegative. Than H. You know what it does? It pulls electrons. And after cooling, do you know what it does? What it acquires? A partial negative charge, leaving a partial positive charge on hydrogen. More intuition. Real life animation is here. This is the real life animation. Share whole screen, share entire screen. It is here. This is HCl. Hope you are seeing. Is there? That is HCl. Are you seeing the one in the? I am not good in colors. What is that thing? I'm not good in colors. What is the color of this thing? Or purple thing? This color here. Edit. This color here. You see? Cl. Cl is this side. Then we have a rope there and the edge. You see? Cl is more electronegative. You see the part, the what? The longest part of the rope. Are you seeing this rope? The longest part of the rope is towards the Cl. The longest part of the rope is towards Cl. Cl has more energy than H. Cl has more energy than H. Therefore, Cl attracts strongly. So you see that Cl is acquiring. Are you seeing it? There is even this cursor in here showing you that, yeah, man, H. So it pulls those electrons strongly towards itself. So therefore, it acquires a negative, highly electronegative as compared to the other. Now, do you know what that rope becomes? This rope becomes polar covalent bond. It becomes a polar covalent bond. Yeah. It becomes a polar covalent bond. I hope that is taken care of. Colleagues, I think I have explored. Let me first stop here this. Now the question, okay. The question which you may ask me in the chat, when do you know that this one is more electronegative than the other? That is a very important question. When do you know that? When do you know that one is more electronegative than the other? When do you know? Now, I want to say that for me here, I am applying periodicity. Bonding has nothing to do that. When do you know that? Yeah. Now, the one who is supposed to tell you when to know, the one who is supposed to tell you when to know that one atom is more electronegative than the other will tell you very soon. That is if you are watching this video and you have never encountered electronegativity. I am basically referring to those in senior 5, particularly senior 5 first term. They haven't covered, not gone through electronegativity. Now, in periodicity, in organic chemistry, they teach you when to know that one is more electronegative than the other. Now, for my case, you just stick to my examples here. You may not understand them in terms of atoms here. You understand them in terms of that rope. Yeah. But I believe majority of those in senior, if you have completed senior 5 second term, then you know what electronegativity means. Senior 6, you know what electronegativity means. It is not a new term. It is not a new term. It's a common term. But still, if it is a new term, I have explained. Please, I have explained. If you have questions, type in the chat. I'll respond to those questions. My contacts, if you want my contact, you ask for it. You'll find it in the chat. Allow me first to stop here.